It will take centuries to terraform Mars. Mars is a gigantic planet, roughly on the order of half the size of the planet Earth.
Right now, Mars stands as a rugged, arid desert marked by craters and is devoid of apparent life on its surface. However, recent discoveries have unveiled evidence of a bygone Mars that once mirrored Earth, wetter, warmer, and more hospitable. Despite this, direct proof of any life on the Martian surface couldn't be found. The question arises, if Mars had life in the past, how did it influence the planet? And where can we find evidence of its past existence? A recent study delving into these mysteries suggests that a potential Martian ecosystem might have played a role in transforming the planet into its current inhospitable state. The study identifies specific areas on Mars, such as Jezero Crater, currently explored by NASA's Perseverance rover, as promising locations for seeking signs of life. It also suggests the interesting idea that life could be a self-destructive force on planets across the universe. For nearly 2 years, Perseverance has been exploring Mars, collecting samples, and sending back images to the hub to unveil the possibility of life on Mars. Join us today as we reveal the evidence gathered by Perseverance and determine whether life could exist on the red planet. NASA's latest rover, Perseverance, touched down on Mars in 2021 and is currently exploring an ancient dried-up river delta. The mission aims to discover preserved microscopic life that existed billions of years ago in the sediments. Presently, it's unlikely that Mars harbors any living organisms. The rover is actively seeking rock samples for potential return to Earth, marking a historic effort as the first Mars rocks brought back by a scientific mission. The 2020 Mars mission had various objectives, including sample collection and surface topography examination. The primary focus, however, was to determine the existence of past life on Mars. The chosen landing site, an expansive clay crater believed to have once been a lake, was considered ideal for exploration due to its association with past water sources, likely habitats for life. Successfully landing in a crater in February 2021, Perseverance's chosen site was dedicated to the late African-American science fiction novelist Octavia E. Butler. NASA experts estimate that the Jezero Crater housed Mars's longest river, and the lake endured for billions of years. With Mars having existed for about 4.6 billion years, akin to Earth's timeline, it raises the intriguing possibility of past or even current life on the red planet. HEROC, short for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, is a spectrometer designed for Perseverance to identify organic matter in Mars samples. The significance of organic material for NASA lies in its association with carbon-based compounds, typically originating from the excrement or decayed remains of organisms like plants and animals. On September 15th, mission managers reported Perseverance's discovery of organic matter over an 8-mile exploration of the Jezero Crater. While collecting samples from various ridges, the rover identified the largest concentration of organic materials ever found by a rover in 2 samples from Skinner Ridge and Wildcat Ridge. Sananda Sharma, an instrument scientist for Perseverance, noted that the abundance of organic material served as a significant clue. With a mission goal of exploring the possibility of life on Mars, Perseverance has 43 sample tubes, with only 25 to be cased. The collected organic matter is stored on board, intended for transfer to a retrieval lander and subsequent return to Earth for in-depth analysis in a collaborative effort between NASA and the European Space Agency. The Perseverance rover's discovery of organic materials on Mars marked a noteworthy event, though not as groundbreaking as the 1996 revelation when scientists, led by David Mackay, claimed evidence of Martian life. Mackay's team pointed to a meticulously guarded rock named ALH 84001, believed to be a Mars fragment that traveled through space and landed in Antarctica. Displaying the space rock, Mackay initiated a panel discussion on the potential existence of life on Mars. The scientific community, including Mackay's colleagues, found itself divided on this matter. Some, like William Schaap, dismissed the notion, asserting that the world romanticized an ordinary rock. While the discovery of organic matter was significant, it wasn't deemed conclusive proof of Martian life. Today, scientific opinion stands divided, with a 75-25 split. The majority supports the idea that life existed on Mars around 3.6 billion years ago, when the Jezero Crater dried up. Many believe that life may still persist on the planet, while a minority, in single digits, contends that Mars has never hosted life. Perseverance's mission aims to delve deeper into this question. Equipped with cameras, microphones, and samplers, the rover's mission involves collecting over 43 stored samples, recording frequency waves, testing for oxygen, and more on Mars. Upon landing in February 2021, Perseverance was accompanied by the smaller drone, Ingenuity, tasked with gathering airborne samples and data across the planet. The drone has completed 29 flights, setting a relatively brief record for the longest journey on Mars. Now, if Perseverance uncovers evidence of life on Mars, considering its tools and the discussed space rocks, the scenario might be less awe-inspiring than expected. Discovering organic matter near a dried-up crater might not meet the grand expectations. However, imagine if the media reported that the rover found an actual Martian. To make this less sci-fi and more grounded, let's say the evidence takes the form of a fossil of a Martian, nonetheless. As space agencies grapple with the revelation of life on Mars, they face tough decisions and delve into unexplored topics. The primary focus shifts to Earth's implications. Does the existence of life on Mars signify the presence or past existence of other life forms in the universe? Perhaps Earth has counterparts on different worlds with diverse life methods and survival mechanisms. The question arises, where did life on Mars originate? The prevailing scientific belief, extensively debated, is that life began with a unicellular organism evolving into a multicellular one, setting the stage for evolution. If life on Mars followed a similar trajectory, it suggests that life existed on Mars long before Earth. This raises intriguing possibilities, such as the history of mankind, potentially beginning with a Martian meteorite carrying organic matter that sparked the transition from unicellular to multicellular organisms on Earth. Observations from Perseverance, craters, deserts, and the abandoned planet's general geopattern hint that life likely started on Mars. The question remains, could we still inhabit Mars? Elon Musk, the eccentric multi-billionaire entrepreneur, is often perceived as a bored, rich individual seeking pastimes. Despite the divisive opinions on Musk's Twitter posts, his revolutionary endeavors have propelled him to where he is today. Perseverance's discovery of potential life on Mars has reignited discussions that trace back to 1996, inspiring Musk to establish SpaceX, a space manufacturing company with the ambitious goal of eventually populating Mars. While individuals eagerly signed up to be among the first Martians, scientists caution against permanent relocation. The presence of life, while groundbreaking, isn't sufficient justification for leaving Earth. Mars, with its depleted water resources and inability to sustain life on a large scale like Earth, presents significant challenges. The planet's geology and atmosphere are inhospitable for humans, lacking the oxygen and water essential for survival. Moreover, Mars' intense cosmic radiation makes human survival on the planet unlikely. As part of NASA's Mars 2020 mission, Perseverance has joined the ranks of rovers aimed at uncovering signs of life on Mars by collecting organic material in the Jezero Crater. The rover has demonstrated its capabilities admirably. Does this constitute definitive proof of life on Mars? No, but it marks a positive step forward. Perseverance's mission focuses on astrobiology, particularly the search for traces of ancient microbial life. It will analyze Mars's geology, study past climate conditions, lay the foundation for future human exploration, and make history as the first mission to collect and store Martian rock and regolith. Perseverance's mission on Mars extends beyond the quest for life as it delves into astrobiology, aiming to unravel the mysteries of the red planet's geological history and climate. By analyzing the surface of the Jezero Crater, the rover seeks to unearth clues about ancient microbial life, contributing valuable data to humanity's understanding of Mars. This mission represents a pivotal stride in preparing for future human exploration of Mars. Perseverance not only examines the feasibility of sustaining life on the planet, but also pioneers the collection and preservation of Martian rock and regolith. These samples, carefully gathered and caged by the rover, hold the potential to unveil profound insights into Mars' past. As the rover progresses in its exploration, the scientific community eagerly anticipates the findings that may emerge. While the discovery of definitive evidence for life on Mars remains uncertain, each data point collected by Perseverance adds another layer to our comprehension of the red planet's history and its potential to harbor life, past or present. The journey of Perseverance stands as a symbol of human curiosity and the relentless pursuit of knowledge, and offers glimpses into the vast complexities of the Martian landscape. So, this seems enough for today's video. If you enjoyed watching it, please give it a thumbs up and leave a comment to share your thoughts. We will be back to you with another amazing video. Thanks for watching.